Thanks for the introduction, and I'm happy to present here now from the rough sea to the calm water. I don't want to follow up with the water stuff, but I will bring you back into the hardware scene and in the computers cluster world. So a very complex title, unpacking the essential components of high performance and sustainable AI clusters. First of all, I want to introduce a little bit what's Amber and where do we come from and what's our passion. So Amber seems to be quite new on the market, but actually we were founded way long ago in 2006 in Munich by Thomas Kitzler, who already then realized that accelerated computing is the way to go. He then went actually with CFD, fluid dynamics simulation, from the CPU world to the GPU world, and this gave him the chance to interact with NVIDIA then, and when NVIDIA was really small and not that big as it is now. But this was the very initial step for Amber. Then we became, 2016, we became one of the first NVIDIA elite partners, which made it possible to really interact closely with NVIDIA. And 2018, we merged into Aiterra, which is a much bigger company for mechanical simulation, especially for mechanical simulation. And 2022, we realized that the software business and the hardware business together doesn't work that well. So we did a merge out, and now we are Amber and standing on our own feet. And yeah, going through the world with NVIDIA and other suppliers, definitely. Just a rough timeline on what we are speaking about and AI and the development of AI. It started quite early with all the computers. I think I wasn't born at this time. Back then already the need of computing power was already much higher than, much lower than the data, and the compute power was much lower than the need for the compute power. And this didn't change in the last years. The very big thing, the very big opening thing for the accelerated computing and AI was definitely the AlexNet invention, 2012, when everything suddenly, well, many people got aware of what this is capable of. Back then, the compute power doubled every 6 months, and also there, NVIDIA already realized that's the way to go and where to really invent new stuff. And then when the DGX-1, the deep GPU acceleration, came into the world and really made it much more powerful, much more easier to work with these AI tasks and the AI problems. Just after it, the transformers came onto the market, which made, again, the necessity of calculation and simulation much more prominent, but opened the door for new stuff. So you could really simulate proteins, you could train your language models, you can work on pixels, on videos, on text. So suddenly, 2022, this was the eye-opener for everybody. So it became a mass product, or it is available for everybody. That's most of the people which are here now realized it's not just a fiction, it's reality. And Gen AI is in all media, and startups are growing and popping up in every single vertical. And Jensen Huang, the CEO of NVIDIA, just told in the last news, he expects to be the market at $100 trillion of dollars. So, and he also said it's just 10% of the market share is already done. So there's a lot of things that can happen in the future here. The state of the generative AI adoption, I took some notes from a Microsoft report. So it says that there is already return of investment on the investments, on the investments in AI, but not all of the POCs and all of the projects are really successful. So it means only half of it really make money out of it, and only 5%, or at least 5%, have 8 times the invested money back again. So that's massive, but the percentage is not that big. And if you look at the second statement, so the global 2,000 companies, the biggest companies, they plan to really work on this in the future, because yeah, if you don't do it, then somebody else will do it, and then you're definitely out in the future. Just about sustainability, I think the title also had sustainability in there. So why should we always invest into something new? And also there, a very nice statement from NVIDIA is, you have to spend more to gain more compute power, to save more, actually, to save more money. And this is very evident if you look at the numbers from the Titan to the DGX H200, which already has a new version, the B200. But the numbers are speaking for themselves, I think. So it's double the petaflops, nearly double the petaflops, but the 800 times less energy is used for the same amount of calculations. And also, of course, the investment from $130 million to $400,000, it's a massive decline. And so it brings a lot of new possibilities for you. So sustainability means you can invest into, should invest into the new technology to really save money upfront. And why is this all done? So why do we do accelerated computing? We could stick to the CPU world. Why not just go there or stay there? I think it's not the same size, the same scale, but you can see you would need a lot of room, a lot of money, and a lot of energy to do the same stuff on a CPU cluster, which is on the left side, compared to a GPU cluster on the right side. So to stay competitive, here the investment, of course, is crucial. And also you can see the large language model, which can be trained on the same system. There's no comparison needed, actually. So without the GPU technology, it wouldn't be possible. Also, if you go from 1 year to the next year, or 1 year to 2 years after, so it's the development cycle from NVIDIA. So every 2 years at least, there's a new generation of GPUs, GPU clusters. So in this case, it's Hopper or Blackwell. So you can see here also the evolution and the really big step forward which is done. Again here, for training the GPT 1.8 trillion model for 90 days, you would need in 2023, so 2 years ago, you would need like 115 megawatts, I think it is, and 8,000 GPUs. And now it's much more smaller. And the GB200, yeah, it's out in the market, and you can buy it already. So again here, all the 3 slides should summarize. You have to invest to really stay competitive. And we heard it yesterday also on the panel that Europe or Germany or all the regions here, it's a matter of really not losing the traction and losing the competition against the competition from US or from Asia to really stay here competitive. What we see as Amber also in the last years, 2022 was the time when everybody was like, we have to do something. ChatGPT is out, we will need it, we will do it. In the last 2 years, it was like, yeah, let's try something, do a POC, try to find our use cases. So what's first? It's the chicken-egg problem. So let's buy a machine, then find the use case, or do we have a use case, then let's buy a machine. So that's something like a weird situation in many companies. They have a machine, but they don't have the space where to put it. So it's really something like a startup mentality in this field of AI here. But what we see is really, and I joined Amber last year, so it's coming to production. So that the things are really getting mature. You can really work with it, and the use cases are, as the Microsoft paper showed, they pay off, and the investments pay off. If you look at the computational requirements, the development of the requirements over the last years, you can see also a big incline or a rise in the incline in the chart. So you had to really already invest and have competitive machines in the past. So before 2018 or 2019, it was needed really to invest there. But since then, when the transformers kicked in and the models are getting bigger and bigger, you really, if you don't have the newest technology, then you're just far off, and it really doesn't make sense to have one DGX. You have to have more, 2 or 3 DGXs combined, and make the best out of it. Yeah. So you can see the slope it's a logarithmic scale, so it's not linear, it's really exponential. So that's somehow a very interesting development here. For us, so the key factor for generating a good AI factory, where you really can benefit of all the parts, on the top, there's the GPU node. So definitely that's the workhorse, that's where the real generation of the data, the computational data is treated. So that's definitely is the crucial point here. But if you look at the other triangles, for example, the AI storage, we see very often that everybody has the funding and they invest 100% or nearly 100% into GPU nodes, and suddenly somebody says, hey, we need to store the data somewhere. There's no money left. Okay, let's take the old storage. But that doesn't work out because, of course, you have to have I/O input, you have traffic, you have to have a very fast storage system. And also we talked yesterday with the Wecker guys, which have a very fast storage option. Scalability is a big topic. So data is huge and it has to be really accessed in a very fast manner. The triangle there on the right, on the bottom, the internal networking, that's also crucial because, as I said before, not only one GPU node is the thing where you want to go with, you really want to connect the GPU node. So one GPU is okay, or one DGX connect as it is, standalone, can work with huge models, but really the bigger models, you have to connect these together, and that's why also NVIDIA acquired some time ago Mellanox, which is the NVIDIA standard now, the InfiniLink, to really connect two GPU nodes together as if they were one, and this makes the picture much more suitable for bigger problems. And the black one in the middle, it's somehow the glue to glue together all the three triangles. Without software and service, it's nothing. So you can have the best machines, but if you compare it with a car, you can have the best motor, but without tires, it doesn't help you at all. So that's really something which stick together the other three parts. And yesterday there was a panel in the room next door, which was also talking about the data center technology, and that's also something which we see actually not in the future, we see it now, that the data center infrastructure, most of the time, it's a heritage out of the HPC CPU cluster world. So, but now the transformation from the air-cooled systems to the liquid-cooled systems, it's a huge task to really make this possible to also put these huge machines, the GPU nodes, the DGXs, for example, or the GP200s, into these existing data centers. That means you've got much heavier weight, you've got more electricity to provide, you have got much more cooling to provide. So this is a completely different workhorse to fit into a data center, and I think that's a major task to really bring the data centers up to speed again. We also see that Amber, at certain points, we have to offer some kind of a container solution to put the machines in there, and the container is then shipped to the customer because they run out of space in their data center, they run out of electricity or cooling capability. So that's quite interesting because one day you ship some cards, and then the next day you ship a container with a complete system. So it's a very interesting task we do every day. And if you really have funding, then you should go for the big one, the SuperPod, which then is the combination of 72 of these machines, and for 32 of these machines, connected with InfiniBand, connected with storage. So then it's really the best of all. And the funny thing is, it's a reference architecture. So NVIDIA already tested it; they use it themselves. So it's not just something which you have to put together. It's one SU. So you really just order this SuperPod, and of course, first you have to worry about the funding, but that's your job. As I said before, a very important thing is, I just talked now about the hardware, but without hardware, it's also quite important to have the software stack on it, so the AI stack. So on the bottom you see a schematic from the DGX, but on top there are many layers. You have to have some kind of a cluster management system, you have to have your language models, you have to have your training facilities, your training framework. So it can happen that if you have a very nice, powerful machine, but the software stack on the top, it can halve your performance of your GPU. That's really crucial. And there are two different approaches which you can follow here. First of all, you can do the open source approach. So everybody can do his own stuff. So you can collect your favorite solution and put it together. And the other one would be like to go for an enterprise solution, maybe from NVIDIA or other suppliers. But that's something which, of course, you can take something which already has been tested, which is up to date, and which works perfectly fine with your hardware. So you have to decide if you want to be, for example, in an educational surrounding. Maybe you've got power, you've got manpower, you've got the expertise to really work with different user groups and try to get your information from the open source world. But yeah, if once there's some problem appearing, then you have to rely on an email chart, or an email list, or any forum in the World Wide Web. The cluster software itself, on the NVIDIA side, you can share, or you can put your, you can rely on 3 different types. There's the NVAE for enterprise, the base command, and the RAN AI, which are 3 different approaches, or 3 different packages which you can use. The NVAE is like a box full of tools you can use that which are really already customized. You can there are pre-trained models, there are NIMs in there. So it's a matter of, you don't have to start from zero. You really have a good point where you can start from, and whenever you get productive, you have to pay for it. Before it's for free, so then it's really a nice play field to experience yourself. The base command, I will dive a little bit deeper there in the next slides, and the RAN AI is quite new. So RAN AI will be, or is acquired, I don't know the status it actually now, will be acquired by NVIDIA. So that's really the connection point. If you have more than one GPU node, to connect them together, to dynamically allocate between different users, which makes sense. For example, if you have 5 users and not everybody is using the same his GPU every time, so maybe you can share it with somebody else and then give it back on the next time. So it's a dynamical allocation with RAN AI, and I think it brings a huge benefit in the future. And on the base command manager, that's a very important thing. For the next slides will show this matrix, because it's something for to provide to the data scientists and to the real workers with your systems and surrounding, that they can feel comfortable in, and you can really even if you have to reboot the system, easily start again with the system. So networking security is very important, user authentication, GPU settings. So everything is controlled with the base command manager. And as I said, whenever you have to reboot, it starts again with the same settings, and you don't have to worry about it to start from zero. Utilization metrics, they also, of course, are collected and are monitoring the health of your system. So it's a complex system, the DGX, for example, or the AI cluster. So you want to have the SSH connectivity. You want to see if the disk space is how far the disk space is occupied by systems. You want to see if the Docker status or the Kubernetes status is okay. So everything there is a very important thing, because we see also that the utility ratio of these complex systems is, if you don't manage this properly, it's quite low actually. So it's below 50%. So it's something you're investing $500,000, and then the usage is not very high. That's very insufficient. So that's when really these systems like RAN AI and Base Command Manager, they pay off, because then you get the utilization rate high, and yeah, the investment really pays off. And even if you're if you're using the DGX to 100% or more, there's always the option to go into the cloud. So also the base command manager makes it possible for you to go into the cloud, to burst into the cloud. So whenever there are some spikes in usage or some training, where you have to have some capability which exceeds your DGX systems or your compute systems, then it also makes it possible to really seamlessly and with the same settings go to the cloud and experience the same performance. Kubernetes integration. So Kubernetes is maybe more or less the standard already. So it's also there. So you can easily operate and support the different Kubernetes versions and really work with it deeply integrated into the base command manager. The same with the Jupyter Notebook. So when it comes to data scientists and the real workers on the data, there it should be a seamless integration, and that's possible here. So they don't feel they can really put together their stuff, put the data sources, the compute resources into one Jupyter Notebook, and then go from there and really go forward with it. once the health monitoring can really dive very deep into the details of the GPU. In this case, it's if all drivers are okay, if the framework is okay, and it's something which is a predictive stuff. So you want to know already upfront when something is going wrong, and not just when all the lights are red, then have to go to the data center and put out some disks or put out some GPUs. So that's something very important, and it goes that deep that you really see the fan speeds, you see the temperatures, and you really can work on the data on a very detailed level. When working with it, as I said, you have to invest something, and there are always some different users on it. There's Bob, there's Charlene, there's Dennis, there's Frank. And if Frank is using all the GPU all week long, he definitely has to pay a little bit more than, I don't know, Bob, who is doing nothing the entire week. So getting back the allocation of the money or the budget to the detailed people is also quite important for us. And also it's very important if you do POCs and you really want to have the calculation of the ROI then, of the return of investment. That's a crucial point in this case too. Again, the triangle on the left, bottom left, is for storage. And as I said before, storage very often it's a little bit forgotten in this topic, forgotten in this topic. So there's one line or one number there. So for one checkpoint, if you're training your large language model, there's 13.8 terabyte for one checkpoint, and you have to save it somewhere, and at least not far away from your GPU system, or in a very fast way and very organized way. So storage is very important. That's why we really emphasized also our focus. We hired a specialist here, which has a lot of experience in this field, and we really want to dive deeper here because that's something which we see in the future also at a very important point. The trends, where is AI going to, or what is the data center requirement in the future? So what we see is the models are getting larger and larger. So the new Blackwell generation has even more VRAM. The memory is even bigger. So the customers are connecting two systems together to really fit the big models in there. And that's something which we see on the training side, but also on the inference side. So now the big models are coming to market, and there you also have to have the big memory to work with it. And so on the training and on the inference side, the bigger systems are now needed, and we see this really heavily because many companies are now scaling up and investing more. And as I said before, the data center requirements in the future, that's something really, I spoke yesterday with a colleague of the Netherlands. He had a data center and he wants to establish a new one. And he said it's a huge investment and you really have to think it new, because the old infrastructure, the old logic behind it, it's completely upside down now because of the liquid cooling, and much more weight and much more energy is needed. So that's something which we see as the big task in the future. And as Amber, founder, is also here, they are thinking always way ahead. So that's one thing that is very important here, because we don't want to sell the next DGX and the next DGX. We also want to be part of the next wave here. And that's something, for example, that's why we are working together with aiterra. SMC, that's not Supermicro, that's Sustainable Metal Cloud. And that means you just put your AI stuff underwater, not really underwater, into oil, and you really immerse it into a liquid, which brings the huge benefit. I hope you can see it looks a little bit like Starship down there, but it's a matter of really ripping off all the fans and all the moving parts of your GPU and put it into the liquid, and that's the big benefit, because then the thermal issues definitely disappear. You've got a much more stable surrounding there and a longer lifetime of the GPU. So that's it. I hope I could give you a little bit of an overview where the market is going to, where the hardware and software and where Amber is going to work on in the future. And I'm happy to answer some questions, and thanks for listening.